3D printing news Unpeeled, thanks to 3dprint.com. So today we're going to be talking about AM Ventures, which has invested 2 million US dollars in an Elementum spinout called Fortius Metals. So what Fortius is doing is making nanostructured metal alloy wires. And this money is going to be spent on their further go-to-market and the further launch and globalization of their products. And well, this is a very timely investment. So what they're doing is they are making, well, wire DED is exploding, right? Wire DED is a technology that is becoming much more prevalent in aerospace, it's becoming more prevalent in oil and gas, it's being used more and more in defense. And the reason for that is that it's a way to make quite large, for us, right, uh, uh, um, inexpensive metal objects. So if you would want to make like a truss or a large support for something or something that's several meters in size, then blown powder processes and powder bed fusion, all these things typically, don't work so well. Or they're too expensive, or we just simply don't have printers large enough, or we can't make that type of structure. Or you'll have a lot of bending and other types of effects. So wire DED allows you to make a near net shape really inexpensively. We're talking like massive objects that would normally cost thousands of dollars and tens of thousands of dollars in powder bed fusion could be tens of dollars in wire DED. Now, one of the reasons for that is they use relatively inexpensive welding equipment. Usually, then you'll use relatively inexpensive wire. And that's been kind of the mainstay of this industry. And that, of course, reduces your powder. You don't have to make powder. You don't have to make really accurate powder. So it really reduces your cost of the feedstock. What Fortius Metals have done is they come up with a wire. Initially, they came out with an aluminum, a 6061, that performed better than just all the regular stock aluminum wires. So everybody was using the wire that was used for welding and all sorts of other processes. And these guys said, no, we're going to come up with something better. And this produced stronger welds. Now, of course, you have stronger welds through this material, then you have better layer adhesion and you have stronger parts. You get better mechanical properties. Now, if these guys can consistently prove that their wire can get better mechanical properties, then either they're going to, sell it at a reasonable premium and be able to get a lot of market share, I think, as opposed to just the bog standard welding wire, because so far the volumes haven't been there for these welding wire companies to really invest in it, right? So that could be a good market. And if they sell it for a lot of money, if Fortius sells it for a lot of money, then in specialized applications like aerospace and defense and oil and gas, maybe they'll get a good client base. We don't see the demand in wire DD explode as much as the vendors, right? So it's a bit of a crazy situation where this seems like a very timely, very early investment, and the technology itself was sure to find a lot of applications because it can make custom structures and repair things quite inexpensively. This is a bit ahead of the market, but this could very well be something interesting down the line. And so far, by the way, the only player that I know of, at least, that has developed any kind of specialized wire for this application is voestalpine. And voestalpine has made like some progress in the area, but that's it. There's voestalpine and Fortius, as far as I know. So that is, to me, quite notable that these guys are kind of in this exploding market, or said to be exploding market, that kind of semi-unimposed. So that's good to know as well. So Fraunhofer ILT and Aachen has made the Ho Pro. So just in time for the holiday, they've released their Ho Pro 3D technology. This is something that ILT has been working on for a number of years. Ho Pro. I think it's a spectacularly badly named technology. Ho Pro 3D it's by far the worst name of any 3D printing technology. But having said that, it's a very it solves a very, very peculiar, very, very pressing problem. So the pressing problem is quite obvious. Like normally, if you would print something very, very accurately, like at the nanoscale, the micro scale, you're going to be doing this very, really slowly, and you're going to be doing this in a very, really, really small object. And then other times, what you'd want is to embed that detail or that functionality in a much larger object. And then you're going to need another different technology or a different machine. So marrying the ability to print minute details or minute micro size and nano size parts with the ability to attach or make these parts in as part of a bigger component has been a bit of a problem. So what they've done is they've made a scrolling DLP, a scrolling kind of vat polymerization DLP process, and combined it with a laser-based process, a multi-photon polymerization (MPP) process. Both those in the same machine, and at the same time, they have different exposure modes that can be focused on more of like making parts as quickly as you want, or producing things as finely as you can. Now they're working on this with companies like LightFab and Bartels Microtechnique. And essentially, well, yeah, it's kind of like on the illegitimate stepchild of Admatech and Up Nano or something like that. And this could very well be a very applicable technology. The team itself thinks for microfluidics, and microfluidics itself could be a quite quickly expanding market um, in organ on chip or lab on a chip, where we need these really finely detailed structures that can pass around and distribute fluids really effectively. And we need to make these things. There's no real good way to make microfluidic structures in an automated, repeatable, reliable way at the moment. All of it's a bit kind of like semi-improvised. So being able to do this in a way that's really very highly automated and very high volume, that could be a great application in and of itself. And the fact that they're doing this a system that can build relatively large structures and relatively quickly at the same time give very, very good detail is I think an excellent thing. The part size or maximum part size is 60 by 100 millimeters squared. And the team has worked. They've been working on this for a number of years. They've been working on, first they commercialized this, or they made the technology. Then they did this thing called the Panda project, where they have essentially ended the testing and tried to use this in an actual manufacturing type scenario. And now here it is. So I thought this wasn't really widely picked up, and I think these kind of hybrid type technologies could very well in electronics and microfluidics be a great solution. This in front of you is a shot, a very rare shot actually, of the Vulcan Forms facility, one of the two Vulcan Forms facilities. So Vulcan Forms is a startup that came out of nowhere. It's been started by a whole bunch of really, really smart people in 2015. And only very recently, a year or so ago, they released that they had, that they have an array metal 3D printing technology, which is said to be much more productive and low cost than um, powder bed fusion technologies, but in high throughput, low cost, and a very accurate technology that could really kind of get powder bed fusion into the next step, if you will, or to get it into like really actual manufacturing. The company then talked a little bit, but now they've kind of known their array-based metal printing technology is being deployed at two of their own sites, one in Devons, the other one at Newburyport in Massachusetts. One is the high throughput facility, which will have dozens of its own systems, which you can see here are quite large, or very large actually. And the Newburyport would be more of a precision machining solution as well. At the same time, what they then hope to do is to have the post-processing and all the other equipment on site, and to really have all of that integrated into a manufacturing solution that will be able to make tons and tons of parts for their customers. So one of the things I said at one point is that they want to re-architect LPBF. They really want to come up with it they started from the ground up, again, with a new productive solution. Now, we've yet to see, of course, what that will mean for the market, but as a go-to-market, this is notable again. We know that Surat is doing something similar. We know that these kind of things are going to appeal a lot to local lawmakers. Imagine you could say in the United States especially, that you're bringing manufacturing back to Massachusetts, that you're going to have the highest tech manufacturing facility in the world in a particular area. And this is what could be a way for them to really unlock a lot of subsidies and a lot of government support, especially local government support, for these kind of efforts. And that makes it a very compelling way to go to launch a product, really, because they wouldn't have that same advantage if they just sold machines. Also, I should think that producing your own parts for people is a faster go-to-market as well and less complex than making the machine and then shipping it to a customer and supporting it hundreds or thousands of miles away. Layerwise did something similar. The Belgian startup initially started as a service, learned a lot, and then released the machine. We've yet to see if Vulcan Forms is is going to go, is going to keep being a production site company, or is at one point going to release these machines and sell them? We don't know that yet. But on the whole, what we can say is that this is a company that you should be watching, and they don't really talk a lot about themselves, so it's easy to overlook them. It's easy to forget they're there, but they are there, and they are looking to make a real difference in our market. Anyway, thank you so much for your time. My name is Joris Peels. Have a great day.